Hey guys, in today's video I'm going to show you guys how to print nylon on an Ender 3 Pro. Now it's a good idea for you guys to print these plastics in some type of an enclosure. But if you got adequate ventilation in a space, or for example you have your printer in a garage and you can open the garage door, a lot of these VOCs and particles can escape and you get fresh air in the room. I don't recommend you printing in a closed room with nylon, ABS, actually even any plastic for that matter, because over time these VOCs and these fine particles get into your lungs and can cause you guys all kinds of problems. But if you're in a pinch and you need to print something and you have adequate ventilation, you can print nylon without an enclosure. And in this video, I'm going to show you exactly how to do that. So the first thing you're going to need is a good quality filament. For this video, I'm going to be using Easy Nylon by Overture. It's a combination of nylon 6 and nylon 6.6, each one having special characteristics. And when combined, you get a very strong, hard to break, corrosive, and UV resistant plastic. Another thing that you're going to need is to dry your filament. It's a good idea that once you get your filament in, even if it's in a sealed package, that you dry it, because you're not sure of what the warehouse conditions were before that filament was packed. And I'll get into details on each of these steps. Another thing you're going to need is a dry box to print from. Nylon is very hygroscopic, and in just a few hours it'll start to absorb a lot of moisture from the air. That'll result in popping, foaming, clouding, stringing, and poor bed adhesion and layer adhesion in your prints. Another thing you're going to need is a high quality build surface. I highly recommend you guys printing on Garolite G10. Not only does it work with PLA, PETG, nylon, and ABS, but it's the least hassle of materials that I found to use when 3D printing. In most cases, you don't need any kind of adhesion promoters. For example, when you're printing with PLA and PETG, you don't need any stick glue, you don't need any of that stuff. Now, when you're dealing with plastics like ABS, you are going to need some glue stick. But the advantages to using Garolite with glue stick is that the glue stick sticks like crazy to the Garolite, and then the glue stick will also stick like crazy to ABS. But anyway, we'll get into all those details. Another thing that you're going to need is a well-designed fan bracket that doesn't leak air onto the part. What I mean by this is, even though you're not running a parts cooling fan when working with ABS and nylon, the fan that cools the heatsink often bleeds air down onto the printed surface, resulting in warping. So this can be eliminated by using a well-designed fan bracket. Another thing that you're going to need to do is to make sure that your printer is calibrated properly. And by this I mean Z offset. So your Z offset has to be set right. If you are not low enough, you're not going to get good bed adhesion. And if you're too low, you're going to promote stringing. And finally, having the right Cura settings. The Cura settings in the slicer are another key to this. If you're printing too hot, or you're not printing with the right bed temperature, then you're not going to see good success with printing with nylon or ABS. All right, guys, let's get into the details. If you're new to the channel, consider subscribing, turn on your notification bell, and leave some comments. I love reading the comments, and I do my best to get back to you guys as soon as I see. The first thing we're going to look at is the filament drying box. Now, this is one that I have a video on making, and all this is a 3D printed part with a humidity and temperature sensor incorporated into it. And if you look at the bottom, it's lined with foil and has a few vent holes at the top. Inside the box, you're going to need to have some type of thing to circulate the air. All this is a old parts cooling fan from my CR10S Pro V2 with an extension on it and a JST connector at the end. And if you guys want the details on building that and the design files, head over to my YouTube channel and look at the video for creating this filament dryer. It also comes with a little spool holder. And if I can get this thing off of it. So all it is a little stand with some channels built into it that sit on top of your build plate. And you use the build plate as the heat source. You can set your Ender 3 V2 or Ender 3 build plate to 70C. Put the little airflow column on it. Drop your filament spool on it. If your filament spool has a big hole like this one, you can use the centering ring. Push that down. It centers the filament on the column and keeps it from falling off of it. Then take the parts cooling fan, put it on top of your filament, and then finally cover it with the box. Now, all of this you're doing it on the heated surface, and then leave it for about 6 to 12 hours. So after 12 hours, you will have dry filament. The current humidity in this room is 24%, and if you can see, the dry box in the back is sitting at 16%. So the dry box makes a difference. Once your filament is dry, put it in there with some desiccant packs or loose desiccant, and it will keep the moisture that slowly makes its way into the dry box away from the filament. Alright guys, so I'm getting my desiccant packs and I'm sticking them in here. These are some homemade desiccant packs. They work pretty well. And I got my nylon. This is Overture nylon. And I'll put a link in the video description to the exact one that I have here. You want to try to get it in the dry box before the filament cools down. Right now it's pretty warm. The next thing that you're going to need is a good high quality build surface to print on. And I've had excellent success printing on Garolite G10. I can't even say enough about this build surface. It's just fantastic. For dealing with PLA, PETG, and now nylon, it's amazing. The G10 we offer, it's precision cut, thick enough that it stays straight. Right, it's not all wobbly, but if you needed to flex it, it can be bent slightly, and this is all you need to release a part, is just that slight bend. Once you get your Garolite from Amazon, you want to use a Scotch-Brite pad on it. So this is a Type A. This is a very fine Scotch-Brite, and you want to wet this pad. You don't want to do this dry because will release this dust really hard to get in your lungs. So I would recommend wetting this Scotch-Brite, get it all wet, and do this outside, preferably with a respirator and wearing gloves and everything. And then you're gonna rub this diagonally this way, and you're gonna scuff it real good. I mean, you're gonna get this looking matte. If you look at the difference between the build plate that's on here versus how you get it, you can see that there's a big difference in the texture. So this one I went over with the Scotch-Brite and this cross pattern, and I'll zoom in here so you guys can see a little better. You can see the cross pattern here on the Garolite. This is very important because if you don't have this cross pattern on here, you're not going to get the nylon to stick. So just work it till you get that cross pattern on it. So rinse with water, dry it thoroughly, put it on the build plate, and then give it another clean with alcohol. And once that's ready to go, then you got the build surface part taken care of. So here's the stock Ender 3 V2 housing, and I'm running an Altua fan in this particular one. And what I'm going to use to show you the air movement that we have is this this little feather here from my cockatiel. He was so nice to donate it to the cause. But let me put this under here so you can see what I'm talking about. Let me zoom in here so you guys can see a little better. So I don't know if you guys can see that in the video, but there's a severe amount of air movement below this fan assembly. Not so much in this area, but over here you got a lot of air movement. You can see it there in the feather. So this air movement down here causes enough cooling that anything that you try to print that warps easily will warp easily using this fan assembly. So now let's jump over to the minimalist fan bracket so I can show you the updates that I made to it and how I eliminated this air draft problem. So what I have here is the minimalist fan bracket, and this is the current prototype that I'm testing here. And I have again my very non-scientific method here of a feather. Let me show you the air movement that I'm getting under here. Let me zoom in so you guys can see. I'm not sure if you can see that. But there is no air movement down here at all. So one of the things that I was able to do to get this to work like this is to seal up the bottom. So I got this deflector down here, so it can only pull in cold air from the top, can't pull in any air from this area below the nozzle, and that's a way to eliminate air disturbance around the hot end. So let me show you what those changes were. So here I have a stock MK8 hot end installed in the minimalist fan bracket. And how this differs from the previous design is that the previous design had open bottom. So you can see this piece that I added, this piece of material that I added in here in the model, that used to be completely open. So I closed that up. I also closed up most of it on this side. It was totally open, but I left just enough space to run the heater cartridge cable, the thermistor wire, heatsink cooling fan, and 2 parts cooling fans. They all run up this channel right here. So when all those wires are running through this gap is pretty much sealed up. So there's not going to be any air movement coming from this gap here. So anyway, I'll have a link to this in the video description. You guys can pick it up if you haven't already. Those of you that have, thank you for supporting my work. You'll get an email update with the download link. Another thing that I added to this is on this version here, I'm running a high temperature probe, and the high temperature probe, instead of going in the standard probe port here at the bottom, it has a threaded part where the probe is inserted into, and then it threads into the set screw for the original probe. And I'll get you a shot of that here in a second so you guys can see what I'm talking about. But it needed extra clearance to get, since it has a little metal protrusion, it can't go into this gap here. So I had to provide this notch area here. And if you were going to run that thermistor, what you need to do is grind this down using a Dremel or something, and then the wire will sit in this groove, go in through this channel along with this side parts cooling fan, and then out the top. So I'll show you on this one how it's installed. So if you come under here, you can see, let me turn on the light so you guys can see better. You can see it sticking out right there. So that follows that path that I was just mentioning. And if you look on the bottom, you can see that it's pretty much buttoned up. There's not going to be any air movement from there. All right, so let's get back to this here. So now, if you guys are planning to print with a material like ABS, you are going to need to upgrade the hot end to use a all metal heat break. And what I have currently on this hot end is this bimetal heat break that I picked up on Amazon. And my good friend Doug O'Connor has been doing some testing with these, and they are fantastic. So this is a titanium heat break along with a copper sleeve, and both are press fitted together. And what I like about this one compared to the Slice Engineering one is, for one thing, the price. The Slice Engineering one is over $30 for their heat break. This one you can get 2 heat breaks for $8.99. So I picked up a couple of packs of them, so I got 4 in total. And another thing is that if you look inside this the sleeve here, let me get it out of the package so you guys can see better. If you look inside the sleeve, the titanium tube, you can't see the titanium tube. So what they've done here is they drilled for the titanium heat break, but there's a countersink in here with a stopper on it. So this titanium sleeve slides in till it hits a stopper, and it can't go in anymore. The Slice Engineering version is drilled all the way through for the diameter of the heat break, the titanium sleeve, and then it's press fitted into the copper housing. But what I don't like about it is that since there's no stopper for the sleeve, if you over tighten the 2 side screws of the MK8 hot end, it is possible to push the sleeve out of position, and that'll mess up your heat break. But anyway, yeah, I encourage you guys to look at this. Again, I'll leave the link in the video description so you guys can check it out. But this is one of those things that you're going to need to upgrade if you plan on printing with high temperature materials. And lastly, for the hot end upgrade, you're going to need a high temperature cartridge. So this is a 60 watt cartridge. Pick these up on Amazon. They were $19.99. You get 5 of them. And I'll leave a link to this item also in the video description so you guys can check it out. So to be successful at printing with nylon, you got to make sure that your Z offset is set correctly. If you're too high up off the build plate, you're not going to get enough squish for the nylon to stick to the Garolite. So that's one thing that you need to get right. And I'll fire off a test square here so you guys can see what it's supposed to look like. That way you guys can set up your printer to look the same as the sample that I'm going to produce for you. And once you do that, then your nylon will stick to the build plate. As far as Cura settings go, I'm printing at 230 degrees, which the manufacturer suggests 260 and above, but I found that at 260 and above, it's just excessive stringing and oozing all over the place, and it creates a huge mess. So what worked well for me was printing at 230C. And guys, if you're going to print at 230C, you really don't even need to upgrade your hot end if you plan on printing with Overture Easy Nylon. Because the hot end with the Bowden tube lined sleeve is good for 240 Celsius. So you can easily print Overture's Easy Nylon with a stock hot end. Now, if you're going to get into ABS, you're going to need to change the 2 components that I just mentioned. All right, so let's fire off a quick test print here. And lastly, no heat on the bed. No heat on the bed at all. All the websites and YouTube channels talk about printing at 70C, 80C, but you don't need a heated bed. The heated bed, along with the air that comes down off of the heatsink, is what causes the warping. And if you're using Garolite as a print build surface, the prints will stick provided that you have the Z offset set correctly. Now, I will tell you that if you want additional insurance to make sure that your parts stick and do not come off, I mean, there's no chance they're going to come off during a print, you can apply stick glue to the Garolite. So the stick glue sticks like crazy to the Garolite when the Garolite is hot. And it also sticks like crazy to the Garolite when the Garolite is cold. What doesn't stick to the Garolite when it's hot or the stick glue is the nylon. So if you heat up the bed, even if it's got stick glue all over it, the nylon will warp. If the bed is totally cold and has glue stick on it, the nylon will stick like crazy to the stick glue. And it sticks so well that it's hard to get off. So let me go ahead and fire off a test print real quick, and I'll show you how that goes. All right, guys, I'm going to give this a quick clean. So this is just a little alcohol. And you don't have to do this. You don't have to do this every print. But it's a good idea if you've been touching the build plate to remove parts, that you do give it a quick wipe down. And this will make sure that there's no oils from your fingers that settled on the build plate. All right, so let me show you what your Z offset should look like, or at least the bottom of your print should look like when you get your Z offset right. Put you guys down here so you guys can see what's going on here. So if you look carefully here at this print, you got line definition, and you're not too squished, right? So if you're too low, then you're gonna be dragging the nozzle through. So you want this amount of squish right here. So if you look at these lines right here, they're almost completely out to the edges, almost touching the next line. So that's perfect right there. And I'm running a 0.3 millimeter gap on this brim, and that's perfect for the nylon, because the nylon is a tough material to deal with this brim. So if the brim is too close, you're not going to get it off. But 0.3 with the right Z offset, you'll be able to remove it pretty easily. So anyway, that's what you need it to look like. Okay, once you get it like that, then you know your Z offset is correct. Let's load up a model in Cura, and I want to print a couple of parts for the Ender 3 Pro. And one of the things that printer was missing was the spool holder, the metal bracket that normally comes with the Creality printers. And I'm also going to need this part. This is so that I can attach the spool holder on the bottom extrusion. So I'm going to put it on the left extrusion. So I need to mirror this because it's the wrong side. So to do that, just select the mirror tool. I need to flip this around the other way, so it looks just like this. and yeah, it prints just like this, so you don't have to change the orientation on this part. This will print just fine, just the way it is. All right, so I'm gonna go over these settings real quick. For walls, I got it set currently at 6. Top and bottom layers are 6. Ink fill, I have 18%. And under the material setting, I'm printing this Overture Easy Nylon at 230 degrees Celsius for all of these settings here, and 0 build plate temperature. So you need no heat at all on the bed. Print speed is 100 millimeters a second. And my travel is the same that I use on PETG. So whatever settings you have for retraction distance and speed, those will work just fine for nylon. I'm not using any cooling. This model doesn't need supports, but I got my supports on anyway. And I usually set my support overhang angle at 80 degrees. That eliminates it putting support material in places where it doesn't need to be. For build plate adhesion, I'm running a brim with 10 lines. And that's pretty much it. Under experimental, I like to keep the slicing tolerance at exclusive if you're dealing with threaded parts that need to fit together. If you're dealing with standard parts, middle is fine. And one more thing, under top and bottom, is I like to use this monatomic top and bottom order. This gives me a nice clean top layer with even lines. Anyway, experiment with this setting because it's pretty cool. All right, let's send this off to the printer and we'll print it. All right, guys, our part just finished. Let's take it off the build plate and check it out. What I like to do to get it off is just lift the brim a little bit along the edges. If it's real stubborn and it doesn't want to come off, you can take the build plate off the machine and give it a flex. It should pop right off. You can see what I mean. There's no stick glue or anything on it. And it sticks pretty darn well. There you go right there. So a lot of the videos that I've seen on printing with nylon have it warping real bad. You can see here that this thing is Perfectly flat. No gaps or anything. Yeah, pretty awesome. Yeah, that's a good looking part. Strong too. Alright guys, that's it for this one. If you guys are new to the channel, consider subscribing, turn on your notification bell, and leave me some comments. I love reading the comments and do my best to get back to you guys as soon as I see them. Till the next video guys, take care.